Hello students and welcome to the quick solution of All India Cast Test Series JEE Advanced 2019 Test 5A Paper 2 Code ENF Physics. Let's move to question number 1. In question number 1, the energy of a system as a function of time t is given by this expression where alpha is equal to 0.2 second inverse. The measurement of A has error of 2%. If the error in measurement of the time is 2%, then percentage error in the value of ET at t equal to 2.5 second is p%. Find the value of p. So it is given that E is equal to a square into e raised to the power minus alpha square into t square. So if I take ln E, then it is equal to 2 times ln A minus alpha square into t square. So if I take the differentiation of this equation, then it comes out to be delta E divided by E is equal to 2 times delta A divided by A plus alpha square into 2t into delta t. So I am dividing by t and multiplying by t, so it becomes 2t square, and I am taking this in percentage terms. So the percentage error delta E by E is equal to 2 times percentage error in A, that is 2%, plus alpha square, the value of alpha is 0.2, it's a square, into 2, the value of t is 2.5 square, and the percentage error in time is also 2%, so that is 2%. So if I solve this, it comes out to be 4 plus 1 is equal to 5%. So on comparison, the value of p comes out to be 5. So the correct answer for question number 1 is 5. Let's move to question number 2. In question number 2, a point mass m is released from rest at a distance 3r from the surface of a uniform solid sphere of mass 3m and radius r along a tunnel which passes through the center of solid sphere as shown. The point mass and the solid sphere are free to move due to their mutual gravitational force. If the maximum speed of the point mass is given by this expression, find the value of k. So we know that the maximum speed of the point mass occurs when the point mass reaches to the center of the solid sphere. So the loss in potential energy is equal to the gain in kinetic energy. So that can be written as initial potential energy is minus g into small m into 3m divided by 4r minus of final potential energy is 3 by 2 of potential energy at surface, so that is minus g m into 3m divided by r. So that is equal to half into reduced mass of system, that can be written as m into 3m divided by 4m into v relative square. So if I solve this equation, the value of v relative comes out to be under root 10 gm by r. Suppose at the instant when the particle reaches to the center, its velocity is v in this direction, then 3m will moving in upward direction with a velocity v by 3. So the v relative can be written as v minus of minus v by 3, so plus v by 3, so it is equal to 4v by 3. So from here the value of v comes out to be under root 45 by 8 gm by r. So on comparison, the value of k comes out to be 8. So the correct answer for question number 2 is 8. Let's move to question number 3. In question number 3, a uniform rod of mass m and length l is free to rotate about its pivoted end. It is initially horizontal and then released from rest. The tension T at the midpoint of rod when rod becomes vertical is 1 plus n by 8 mg. Find the value of n. So at the instant when the rod becomes vertical, let its angular velocity is omega. So applying the principle of conservation of mechanical energy, I can write mg into L by 2 is equal to half into I, that is ml square by 3 into omega square. So from here the value of omega square comes out to be 3g by L. Now if I consider this segment, the tension at this point is T. Let this is the pivoted end and this separation is L by 2 and this separation is L. So if I consider an element at a distance x of length dx, then the tension on this element can be written as dm, that is m by l into dx into omega square into x. And if I integrate this value from L by 2 to L, then I will get the tension at this point due to rotation. So that is x varies from L by 2 to L, plus the gravitational force acting at this instant is mg by 2 on this segment. So this is the net tension at the midpoint. So if I solve this, it comes out to be mg by 2, and this value comes out to be 9 by 8 of mg. So on further solving, it comes out to be 13 by 8 mg. So on comparison, the value of n comes out to be 5. So the correct answer for question number 3 is 5. Let's move to question number 4. In question number 4, a free particle of mass m is confined to a region of length L. The de Broglie wave associated with the particle is sinusoidal in nature as given in the figure. The kinetic energy of the particle is given by this expression. Find the value of n. So the kinetic energy of the particle is given by p square by 2m, where p can be written as h by lambda from the de Broglie hypothesis. So we can write in this way, this is equal to h square upon 2m into lambda square. Now if I see this sinusoidal wave, then the wavelength lambda is the minimum separation between 2 points which are in same phase. So this separation is lambda, and this is equal to L by 2. So if I substitute the value of lambda is equal to L by 2, then it comes out to be 4h square divided by 2m L square. On further solving, it can be written as 2h square divided by ml square. So on comparison, the value of n comes out to be 4. So the correct answer for question number 4 is 4. Let's move to question number 5. In question number 5, in the given circuit, the power developed across the resistor R is 11 p watt. Find the value of p. It is given in the question that the potential difference between these 2 points is 40 volt. So the current in this branch is 40 volt divided by 20, that is 2 ampere. So let I have assumed the direction of current is in this way, that is 2 ampere. Then the current here, it is 4 ampere. Now if I redraw this circuit, then this is 4 ohm, this is 20 ohm, this is 100 volt battery. Here it is resistance of 4 ohm, that is the equivalent of 6 ohm and 12 ohm. And here it is R. Here it is S. Current here it is 2 ampere. Here it is 4 ampere. The 2 ampere is coming from this side. Then 2 ampere goes in this side and 2 ampere goes in this side. So if I take the loop equation, then I can write 4 into 4, that is 16, plus 2R minus 100 plus 40 is equal to 0. So this is KVL equation. On solving, the value of R comes out to be 22 ohm. So the power through the resistor R can be written as I square R. So 2 square into 22. So it comes out to be 88. So on comparison, the value of P comes out to be 8. So the correct answer for question number 5 is 8. Let's move to question number 6. In question number 6, a stationary source emits sound of frequency f0. The sound is reflected by a large car approaching the source with a speed of 2 meters per second. The reflected signal is received by the source and superposed with the original signal. What is the beat frequency of resulting signal in hertz, given that the speed of sound in air is 330 meters per second? So let this is the source and it is the stationary source, and here is a car which is moving in this direction with a speed of 2 meters per second. The speed of sound in air is 330 meters per second. So when the sound is emitted by the source and it is received by this car, then the frequency received by the car is given by, is f0 is this frequency, then f0 into 1 plus 2 by 330. Now whatever is this frequency received by this observer, the same frequency will be emitted by this observer, and then f2 is the frequency observed by the original source. So the value of f2 can be written as f1 divided by 1 minus 2 by 330, as this observer is at rest. So the beat frequency is f2 minus f0. So if I substitute the data and solve, then it comes out to be 6 Hertz. So the correct answer for question number 6 is 6. Let's move to question number 7. In question number 7, a thin plano-convex lens fits exactly into a plano-concave lens with their plane surfaces parallel to each other. The radius of curvature is 30 cm. The lenses are made of different materials having refractive indices mu1 is equal to 3 by 2 and mu2 is equal to 5 by 4 as shown. If plane surface of the convex lens is silvered, then the equivalent focal length of the system is 10k cm. Find the value of k. So from the theory of equivalent power, we can say that P equivalent is equal to 2 times P1 plus P2, where P1 and P2 are the power of this lens and this lens plus the power of plane mirror. We know that the power of plane mirror is 0. The power of P1 can be written as 1 by F1 and the power of P2 can be written as 1 by F2. Since the equivalent system will behave like a mirror, so its power can be written as minus 1 upon F equivalent. Now we have to find out what is the value of F1. So from lens maker formula, we can write 1 upon F1 is equal to 3 by 2 minus 1 divided by 1 into the radius of curvature of this surface is infinite. So 1 upon infinite is 0 minus the radius of curvature of this is taken as positive. So minus 1 by 30. So on solving, it comes out to be minus 1 by 60. Similarly, if I calculate the value of F2, then 1 upon F2 can be written as 5 by 4 minus 1 divided by 1. The radius of curvature of this part can be written as 1 by R. So 1 by 30 minus of this surface is 0. So on solving, it comes out to be 1 divided by 1 by 20. So if I substitute this value here, this comes out to be minus 1 by 20. So on solving, the value of F equivalent comes out to be 60 centimeter. So on comparison, the value of K comes out to be 6. So the correct answer for question number 7 is 6. Let's move to question number 8. In question number 8, a vertical cylindrical container of height 90 cm and diameter 40 cm is partially filled with 60 cm high water. Now the cylinder is rotated at a constant angular speed of 120 rpm. The liquid level at the center of the cylinder will drop as a result of this rotational motion. If the drop is 2x centimeter, then find the value of x. So let's understand the situation. Suppose this is a cylinder. The radius of this cylinder is given as r, which is 20 centimeter, and the level of liquid in this cylinder is given, that is h0 initially, and that is given as 60 centimeter. So when this cylinder is rotated with some angular velocity omega, where omega is given as 120 rpm, so 2 pi divided by 60, so it comes out to be 4 pi radian per second. Then the level of liquid in this cylinder will be like this. Now it is given that this drop is 2x and we have to find out what is the value of x. Now if I consider the center at the bottom of the cylinder as my origin, and the height of the liquid surface from this will be h, and this is at a distance r. Then the equation of this free surface is given in terms of h as h naught minus omega square by 4g into capital R square minus 2r square. So it is the result which I am using. So I have to find out the height of the liquid. So when r is equal to 0, I have to find out what is the height. The value of h naught is given, that is 60 centimeter is 0.6 meter minus omega square. So the value of omega square is 16 pi square divided by 4 into g. The value of g is pi square into, when small r is equal to 0, then this expression is r square. So the value of capital R is 0.2, its square. So if I solve this, it comes out to be 0.44 meter. It means the drop 2x is equal to 0.6 minus 0.44. So it comes out to be 0.16 or 16 centimeter. So the value of x comes out to be 8 centimeter. So the correct answer for question number 8 is 8. Let's move to question number 9.